Hello everybody. Also on behalf of our team, there are three of us. I'm Andrea Zimmermann, coming from Faculty of Economics, and my presentation will be followed by Mrs. Blaženka Pošić-Perpar from EURL3A and Matija Štukal from the Faculty of Economics, a master student at the Faculty of Economics. So if I refer first to the previous presentation, you know, sometimes you don't need a lobotomy to change behavior. Even prices can do quite a wonder in how you can change behavior. And energy efficiency and chasing energy efficiency is actually a response in a long, quite strongly an effect of increasing energy prices. So there is a chase for megawatt hours or chase for so-called hidden fuel, and this chase actually means that it extends the energy supplies, it increases energy safety, decreases the risk associated with getting the energy we need, and it's also very good for the environment. So the energy efficiency is really getting a momentum. It is a huge and increasing industry actually going on worldwide. This is quite a conservative actually estimation of how much this industry was worth in 2011. It's actually, we can see it was almost, it was about 300 billion of US dollars in 2011, which is actually more money was invested in energy efficiency than it was invested in renewable electricity generation or in coal, oil, and gas electricity generation. However, what is depressing is this is still far below to the amount of money that goes for subsidization of fuel, which actually means that the prices should be even higher than they are, and they would motivate the energy efficiency even more. Well, for the energy efficiency, there is a huge room to do more, to chase, you know, the hidden fuel. And in this respect, the technical as well as economically viable solutions are available. However, there are imperfect markets there with asymmetric information, lots of risk, and other problems occurring on the market that actually prevent that this is actually progressing with a higher pace or higher speed. So therefore, it is very important to have facilitators in this process, and this facilitating role in these processes, especially with offering financial as well as knowledge transfer, facilitating role is given to energy contractors. So in the continuation of this presentation, first I will give the word. The first part of this presentation will be given by Mrs. Pošić-Perpar from the EURL3A, which is actually a leading and a very progressive provider of energy contracting solutions in Slovenia, while the second part of the presentation will be given by Matija Štukal, coming as a student at our school. Energy contracting is actually about dividing about investing, and then dividing the savings and the risks of the investment. So risks are really a very important part of energy contracting, and Matija will show how we can use actually the tools that come from portfolio management, which is the so-called energy budget at risk, how we can use these methods to assess the risks that are involved in energy contracting. So I will give the microphone then.
Thank you very much. I will start with a very short presentation of our company, because you know everything what we said in then it comes from our experiences, from our projects, because the slogan of our company, this is energy of a green future, means that all activities and projects implemented by our company are to contribute to the reduction of energy and water consumption and, of course, environmental impact. We are providing the solution on four main business fields: district energy system, water supply system, efficient lighting, and energy management. Today we are talking about energy management, but I won't present our projects and I won't go to details because as it had already been said that we will talk about business model and about risk. So our advance is that we can provide the business model so-called energy contracting. There are three main business models in contracting, energy contracting. So energy performance contracting, energy supply, and if we are dealing with public buildings, there's a public-private partnership. What's about in this energy contracting? There is always some kind of guarantee of effect from this project because the payment is subject to achieved savings. The contractor takes the technical and financial risk, and because there is also we are also financing the investment, and we are guaranteeing the savings. We have to take the control of facilities that we made. I would like to explain you a model of energy performance contracting just in few words. So if the owner of a facility, of a building, has such initial costs, we are talking about energy costs for energy and for maintenance, and then the contractors reduce energy costs with an investment which he financed, then in the certain period, contract period, the savings achieved with these measures, a part of it goes to investor for repayment, and the other part stays with owner. So the owner also participates in these savings. After the contract period, all the savings stays by the owner. Of course, the measures life period has to be longer than contract period. What's about energy performance contractor? The contractor is bound by the contract to perform these measures that bring a certain reduction in energy costs. So energy and maintenance we are talking, and if it's the case also in water consumption. The savings are guaranteed. Guarantees can be different and depends on the contracts. It can be payment from investments, from savings, and this is directly dependence, or it can be guaranteed by other instruments, for example, bank guarantee or subsequent payments. I would like to show you just one project in Slovenia from 2002, because we have history data for this project, and I will show you why. Measures were implemented on 14 buildings, very different buildings. There were office building, here is a historical building of municipality of Kranj, of sports halls and indoor Olympic pool, and others are school facilities. Heat consumption was approximately 10,000 megawatt hours per year, and the guarantee savings are 3,002 megawatts hour per year. Just a quick view on effects of EPC project. I will tell you why I'm showing you this. I won't go into details, just to get the feeling. This blue bar is the consumption of heat. I'm talking just on heat consumption in the baseline year. So in the year 1999, and the other bars are showing us the consumption in the years after the measures were implemented. We can see two things. The first, that all heat consumption, all objects are reducing their heat consumption after the measures were taken, with one exception. We know why, but as I've said, I won't go to the details. There are certain reasons. And another thing that I would like you to remember is how the energy consumption is different from year to year. So after the measures, the investment was made, you see the consumption is very different. And another project from this of this kind is in University of Maribor. This is here because the colleague takes the data from this project. It was in University of Maribor. It has started in 2011, and we have 15 years contract period. So we have a lot of time to make the things better. And that's why we are doing also this project. And also the measures were implemented on different kinds of buildings. And this is University of Maribor Library is the object that we are looking at in after. So here are the numbers. I won't read. I think that you have it there. What measures were implemented there? There was installation of heat meters and temperatures, and the measurements of energy consumption, so we know how the buildings is managed, and temperature and also lighting facilities. And the point is that we renovate also a heat plant. Now I'm going back to risk assessment. What kind of risk are here for ESCO company, so energy service company? The contractors takes all the technical risk. So how was the baseline? So do we have the real data for energy consumption? Do we have proper analysis for baseline? You know, it is a problem. You may have, think that in our nowadays that the data are here, but you know we have problem with baseline. Then how can we provide savings? In what sum? In what amount of savings can we talk? If we promise the too high savings, then it can be your balance of a project in minus. But if you promise too low savings, it can happen that the project cannot be feasible. Then we have to choose optimal equipment. Of course, in contract period, you see that the contract period should be shorter than life period of equipment. And also, how can we estimate investment costs? And also, we have to know which cost will be in the contract period. So if ESCO fails to achieve savings, they must cover the difference between the actual and the guaranteed costs. We can manage this risk with acknowledgement, with experience, and also with proper energy management. So with technical devices, equipment that enables easy control, monitoring the operation and the energy consumption in a number of facilities. So we minimize risk factors. But what we cannot do, we cannot take the risk for degree days. So we cannot influence on the weather. Degree days is some measure how cold or warm the day is. So that is called degree day. We cannot have influence on the energy prices. And we cannot have an influence on the changes in use of buildings. But this risk must be taken from the owner point of view. And so we have to deal also with it. And this is the point when where can utilizing of risk management decision tools can be applied on the presented project data, and the colleague will show you this process.
Hello, my name is Matija and I'm a student of Master Program Banking and Financial Management at the Faculty of Economics, and I will present energy contracting and risk management, risk assessment, sorry. First of all, I would like to stress two terms, exactly what is risk. Like uncertainty, risk involves the likelihood of possible outcomes, but usually focuses on negative aspects. Then also, unlike uncertainty, risk has a qualitative connotation. But just for this type of research, because we also know that risk can be also qualitative. And qualitative, yeah. Then the other point is risk management. So how can we perform a security so that we can take risk into the consideration and perform some kind of hedging. Hedging is a process that we can save ourselves, or we can buy for instance contracts for longer period of for gas and others. Also, as it states, risk management seeks to identify the causes of undesirable outcomes, quantify the impact, and manage the results. I prepared a couple of graphs just to make a motivation so that you can understand what exactly or what are the risk factors in which goes into this risk assessment. The first is here you can see that global temperature and carbon dioxide. This is on average, so you can get a picture that on average temperatures are rising. The other is the graph that shows gas prices. You can see that it states that three lines are drawn here, gas price for Europe, United States and Canada. You can see that towards January 2008, all the prices can be or are moving towards the same trend. But then between the January 2008 and January 2008 and January 2010, something came up. Well, I spoke with traders, and they explained that this is because of most of it because of fracking. Fracking is a technology that's uses companies are drilling I don't know 2, 3 or 4 miles into the earth, and they're pushing compressed air and explosions to get the gas out. But why this is interesting is because you can see that the lines of United States and Canada are more or less the same, and they are saying that also the price of the gas in Europe will drop. There are a couple of facts about it. The fracking is already becoming to get used in Poland. Then the gas from the United States, it's coming to Rotterdam, because in 2015 they will open a gas terminal. Then also the gas from Russia, so we can anticipate that the price of gas will drop. The next graph is showing an average winter temperature of air in Ljubljana, so you can also see the trend that the temperature on average is getting, or the temperature of winter is getting warmer, and the other picture is showing also the positive proof of global warming. The solution is an EBER method. It's a commercial name for the risk assessment. Different authors are using this method, but Jerry Jackson made a biggest breakthrough, if I can say. He put it out the book, and he's marketing this method. The EBER stands for energy budget at risk. It refers, like Professor Zilman said, to VAR, value at risk. Value at risk was introduced by JP Morgan Bank around 1974. VAR is used for banks to calculate what are their risks inside their portfolios, and value at risk is one of the most international used measurements. So we are using it also in Slovenia, Russia, Brazil. It's very well known all over the globe. What is most interesting is that where there is volatility, there is money, because companies that they are selling hedge products, they are well aware of that. EBER offers a financial risk management tool for energy efficiency investment. We heard before about payback period. What EBER does, it puts a negative, in brackets, light towards usual methods that companies use for evaluate energy efficiency investments. Payback is used to avoid risk when uncertainty cannot be quantified. Payback is inappropriate decision criteria for energy investments, questionable selection of uncertain energy prices, etc. But let's not forget, energy efficiency projects are competing with other investments internally and externally, meaning that if you are an energy manager and you want to close the financial construction for the project inside of your company, the CFO or the general manager will seek from you the measurements, and he will compare it towards another investment. So this is internally and also externally. So if you go to the bank, the banking manager or the office for which calculates the risk will try to get the information from you. What are the risks? So if the risk is too big, they will not give you the money. They will give the money to other investments, like for transportation or something else. In the EBER, Monte Carlo analysis is used. This is a quantitative analysis. It was developed for Manhattan projects. This is for modeling nuclear explosion. What the Monte Carlo does is that it used three types of distributions for the weather, performance, and energy price. and it combines it into one unificial, if I can say, distribution that can be put out as a budget or as you will see on the next slide towards savings. EBAR, Energy Efficiency Investment Analysis Case Study. You can see on the top of the left the distribution that it was drawn, if I can say so. 10,000 iterations were performed, and EBAR budget mean was 41,848 euros. This means that energy manager can plan on a budget of 41,000 euros with confidence that energy budget will not be greater than 8,200 euros. This also depends on the company's decisions where to put the limit of the confidence, but this is for the budget. You will see that in energy budget at risk, you have two distinct process. One is that it tells you what will your cost be if you don't do nothing, and on the other slide you will see if you invest in heating plant. The distribution was also drawn from 10,000 iterations, and it shows that investor can expect annual net cost flow increase between mean was 6,700 and 8,380 euros. So that's